Hello GMS students, this is Mr. Friedman, and today we are going to be looking at solving systems of equations using the elimination method. Now before you begin today's lesson, please download the guided notes which are up on Google Classroom. If you have a printer, you should print them out. If you do not have a printer, please copy down example 1 and example 2 so that you can follow along as I go through these. So once again, we are looking at systems of equations. Now, last week, we looked at systems of equations that were all in what we call slope-intercept form. This is the form that you are most familiar with for linear equations. Y equals mx plus b. Remember, we said m is the slope and y is the y-intercept. So an example here is y equals negative 5x plus 4. And we learned that you can solve these by graphing them, or when we have a system of these equations, we can set them equal to each other. Now, sometimes a linear equation has a different form. So you will see as we get to word problems, not all problems lend themselves to this form. Sometimes our equation is going to be in what we call standard form. ax plus by equals c. So this is where our x and our y are both on the same side of the equation, and they may both have coefficients in front of them. So an example here is 3x plus 2y equals 8. So that is standard form versus what we had before was slope-intercept form, where we have y equals mx plus b. So today we're going to be looking at how do we solve a system of equations where both equations are in standard form. Let's look at example 1. We have 3x plus 3y equals 6 and 2x minus 3y equals 9. Now, I can't solve this system by setting the two equations equal to each other, like we did with the equations in slope-intercept form. I can't say 3x plus 3y equals 2x minus 3y, because these equations don't equal the same thing. So I can't set them equal to each other. But what I can do is add the two equations together, and that's going to allow me to eliminate a variable. Now let's think about this, why I can add these equations together. I have in my first equation, the left-hand side is equal to the right-hand side. That's also true in my second equation. The left-hand side is equal to the right-hand side. So since my left-hand side always equals the right-hand side, I can add what's on the left and add what's on the right, and the equations will still be equal. So let's do that. I'm going to add my two equations. Okay, when I add 3x and 2x, I get 5x. Now let's look at this. When I add 3y plus negative 3y, that becomes 0. It's what we call a zero pair. So I'm just going to cross that out. I don't even need to write plus 0. That cancels out. 6 plus 9 is 15. Now what's happened here is I now just have one variable. I eliminated, by adding these equations together, I eliminated my y variable. So now let's solve for x. Divide both sides by 5. And I have x is equal to 3. Now my next step is to go back into one of my equations to find the value of y. Let's take my first equation, 3x plus 3y equals 6. I already know the value now of x. So I'm going to put a blank space. Okay, so we see here, I just copied this first equation, but I left a blank for x because I know that x is equal to 3. Okay, now let's go ahead and solve this equation. 3 times 3 is 9. I have 9 plus 3y equals 6. Subtract 9 from both sides. And I have 3y is equal to negative 3. Divide both sides by 3. And I have y is equal to negative 1. So my solution to this system of equations, it's right here, the solution is 3, negative 1. Okay, one last step here is I need to check. Now to check, what I'm going to do is check this solution in both of my two equations. Take equation 1, 3x plus 3y equals 6. Plug in my numbers here. 3, negative 1. 9 plus negative 3 equals 6. 6 equals 6. That checks. Let's look at our second equation. 2x, put a blank for x, minus 3y equals 9. And we're going to plug in our values for x and y. X is 3, y is negative 1, 6, and minus negative 3 is going to end up being a plus 3 equals 9. Okay, so I have checked that. All right, now we're going to do one more example here. Let's look at example 2. I have a system of equations, 3x plus 2y equals 0, 5x plus 2y equals negative 4. Now the problem with this equation is that if I add these together, neither of my two variables will eliminate. I don't have a zero pair like I did in this case. It looks like I might. I have 2y in both equations. But if I add 2y and 2y, I get 4y. So neither of these variables are going to cancel out when I add the equations together. But what I can do is I can multiply the equation through by a number so that it will cancel out. So what I'm going to do here is I'm going to take the second equation and I'm going to multiply this whole equation through by negative 1. And I have to do this on both sides of the equation. You're going to see why this allows me to cancel out a variable. So what this equation becomes, negative 1 times 5x. This becomes negative 5x. Negative 1 times 2y is negative 2y. And on the other side, remember I have to multiply both sides of this equation to keep it true. Negative 4 times negative 1 gives me 4. So by multiplying through by negative 1, this equation now became negative 5x plus negative 2y equals positive 4. That's my new equation. Now let's copy down this first equation here just so I can work with it. I'm not going to change it at all. Just recopy this first equation. 3x plus 2y equals 0. So this is my new system I'm working with. Now let's look at this. Now I do have a zero pair. Now I can add these together and my y will cancel out. Okay. Negative 5x plus 3x gives me negative 2x. My y's, I have a negative 2y and a positive 2y. That cancels. Equals 4. Divide both sides by negative 2. And I have x is equal to negative 2. All right, now we need to solve for y. Let's take my first equation here. 3x plus 2y equals 0. I left a blank space for x because I know that x is equal to negative 2. So I get negative 6 plus 2y equals 0. Add 6 to both sides. 2y equals 6, or y equals 3. Okay, so my solution here, if I write this as coordinates, is negative 2 and 3. And for our last step, we're going to check. We want you to check. Always check your solutions here. That way we know we have it right. We're going to check in both equations. Okay, take the first equation, 3x plus 2y equals 0. Let's plug in the solution we came up with, negative 2 for x, 3 for y. And I have negative 6 plus 6 equals 0. 0 equals 0. That checks. And let's look at our second equation. Go back to the original equation, 5x plus 2y equals -4. Put in our solution that we came up with here. -2, 3. So I can -10 plus 6 equals -4. -4 equals -4. So that is how we solve our systems of equations by elimination. So the main thing you need to look at today is, do I already have a zero pair? Do I have variables that will cancel out as I did in example 1? Then we can just go ahead and add. Or if I don't, if I have a variable with the same coefficient but they both have the same sign, then we need to multiply one of the equations through by -1. And then we can add those together. And just always make sure when you multiply by that -1 that you multiply both sides of the equation and that you multiply all of the different terms. Now you should be ready to begin today's assignment.